Hi everybody, I'm Suraj Chhetri. I'm an optometrist and today I'm going to talk about concept of vergence in optics. Why I'm talking about concept of vergence because concept of vergence is very important when you're dealing with the optics and dealing with calculations, which is too lengthy. But with concept of vergence, we can do a very faster and very quick. So vergence by definition is the way to quantify in the curvature of wavefront. So that's why we have to understand what is wavefront first. So you can imagine wavefront. It's like there's a quite pond, and you are throwing a stone, and how pebbles move away from the dropping point. So this is dropping point. This is the point source, and it emits light all over the world, all over the area, and you can get wavefront. This is wavefront. By definition, wavefront is imaginary surface representing corresponding point of wave that vibrates uniformly. Uniformly means in all imaginary point the vibration is exactly the same peak and same time. So so by definition, when identical waves having a common origin travel through the homogeneous medium, the corresponding crest and trough at any instant are in the phase, that is, they have complete identical fraction of their cycle motion, and any surface drawn through all the points of the same phase will constitute a wavefront. So if we tick there, then there is the same time and same top and croft and all that. And you can also see, if we move from point source to away from, then curvature of wavefront decreases, and when we travel enough distance, then curvature of wavefront is parallel. It's parallel, it's straight, and then I can show you that. And you have to understand as a student that light ray and the wavefront are always perpendicular to each other, always perpendicular to each other. This is real important thing you have to understand. These two things are perpendicular, the straight line and the wavefront. If the wavefront is straight when it travels a lot of distance, then by definition lights are parallel. So that's why when light comes from sun or for enough distance, we consider it a parallel, because of wavefronts are parallel and light also parallel, but at exactly 90-degree, exactly perpendicular. So let's come to the same concept. When point source we travel from one distance away and large distance gap, then wavefront become parallel, and as I said earlier, the light rays and wavefront are always perpendicular, so light rays are parallel. So this is the same concept, we just add rays and wavefront. Then you can see the curvature of wavefront is more when the distance is less, when the distance is less, and when distance goes away, the curvature of wavefront is flatter and flatter and flatter when it becomes parallel. So that's the concept. And now I can show you that in this figure. This is a very amazing figure. This is a plus lens. When a point source always and always, just understand, point source always gives a divergent light, never convergent light. But if you want to get convergent light, then you have to add plus lens. So point source create divergent light, and it strike to the plus lens, and it gives convergent light, and it is point source again, light becomes divergent. So in this figure you can understand there is a point source, and light comes here with plus lens, and it converges at the focal point, then again it diverges. So if you want a vergence at this place, then this is the distance. If you want a vergence this place, then this is distance. You have to understand that it's not always from point source. it's, it can be from focal point. The many students didn't understand this concept, that they always take from point source or from certain object in real object, but that's not the case. You have to understand that if B is a point source, a focal point, then vergence at A and vergence at C should be calculated from here, not from point source here. This will be mistaken, because here is a plus lens, it changes vergence, and now we have to calculate vergence at that point from focal point, vergence at this point from focal point. And you already know, and I hope you know, that vergence is reciprocal of distance. That's why the vergence of this place is quite larger than this place. So I can show you in next figure that how we can understand distance in centimeter, point source, and if we take 1 centimeter, which is 1 divided by 1 divided by 100 meter, so it is minus 100 diopter. Why minus? Because it's divergent. So in 100 centimeter, which is 1 meter, 1 by 1 is equal to 1 diopter. Why minus? Because it is divergent. So at the same point, if light comes parallel or whatever form, it is a plus lens, then it converges to the focal point. Then we have to take a distance from here, not from here. So take a distance from here. If it is 5 centimeter, then 1 divided by 5 divided by 100 to do meter, which is 20 diopter. Why plus? Because it is convergent. Let's say 20 diopter. 1 divided by 50 divided by 100, which is 100 by 50 is equal to 2 diopter plus 2 diopter. Why plus? Because it is convergent light. It's so important. And another thing, we take as an optometrist optical infinity, we at 6 meter, because we presume when the light source travel from it's 6 meter, which is distance 6 meter, it is optically infinity. That's why we take visual acuity chart at 6 meter. This is another important concept you have to understand. And I just want to add something, that you have to calculate, you have to think like this. Suppose this is the point source and it emits divergent light and has the plus lens. Suppose this point source is 10 centimeter away, which is the light striking here is minus 10 diopter, isn't it? Because 10 by 100, 100 divided by 10, which is minus 10 diopter. If this lens is plus 8 diopter, then again light diverges, not converges, because minus 10 plus 8 diopter is equal to minus 2. Now the diverging light has a divergence of minus 2. If, let's take another example, if there's a point source and it is 10 centimeter here, and if it is plus 10 diopter, then light must be parallel, because minus 10 and plus 10 is parallel 0. So another example, if there is a point source and it's 10 centimeter away, which is, we know 10 diopter, 10 diopter divergence light, and if there is a plus 12 diopter lens, then you can add it, which is plus 2, so it focuses on 50 centimeter from here. This distance must be 50 centimeter. So this is the concept you have to understand as a student to solve many problems in optics. If you don't get this concept, then you will lose sight of many equations or many problems in Vergence. So this is it. Thank you so much to hear me, and I'll meet you in the next video. Thank you so much.